Shall we get started? Am I audible?
Yes, sir.
Okay. Shared my desktop itself. So today's class, we are going to start with applications of derivatives. Am I right? So before I start, no, I just want to confirm once again, is there any doubt or any concept that is bothering you from the previous chapter, continuity and differentiability? Is there anything you want me to help with? Nothing?
No, sir.
Okay. One thing you're good to go. Just a minute. Okay. Share my desktop. Tell me.
Sir, can you do from the last chapter y equal to differentiate log log base 5x, sir? I got an answer. It's different from.
Come again, 1 minute. 1 minute. What are you able to see? Are you able to see the PPT or the question paper?
Question papers.
Okay. Now we are able to see the PPT, no?
Yes, sir.
It's in 2 devices. Yeah. Come again. What do you want me to help with?
Sir,
Y is
y
equal to
log base 5x.
log x base 5.
Yes.
Is this right? Or 5 by 6? This is the question, no? Log x base 5.
Yes, sir.
So y is equal to log x base e into log e base 5.
Yes, sir.
Okay. So y dash will be equal to log e base 5 is a constant into derivative of log x is 1 by x. That's it.
Sir,
Or
in the it is given ln something.
1 by x log 5 ன்னு கொடுத்திருக்கா.
Yes, sir.
Both are right. ஏன்னா see log e base 5 is equal to log of 1 by log of 5 base e. ஞாபகம் வச்சுக்கோட, there is a property log of a base b is equal to 1 by log of b base a.
Yes, sir. I know it. Yes, sir.
So that's the logic. So 1 by log e base 5 into 1 by x is the same as 1 by x log 5. They both are same.
Okay, sir. Thank you.
Yep. Okay. So we'll get started with the applications of derivatives. Can you tell me what are all the concepts we are going to learn in this, in applications of derivatives? One is rate of change. Second exercise will be concentrating on the increasing and decreasing functions. And third, we'll be concentrating on the part maxima and minima. So 1 minute. You see, These are all the topics that are read. Rate of change, increasing or decreasing function, maxima and minima, tangents and normals, and rate of change, approximation are deleted. So you have 6.1, 6.2, and 6.5. Right? So for my satisfaction, I'll at least explain the concepts, then we can start off with the problems. Okay. So when there are problems based on rate of change, what do we generally do? So they'll give you a question where it has some geometrical figure or something, right? Most of the problem based on rate of change have the geometrical structures. So you need to write the formula, right, of the required parameter of the given geometrical shape. Then what is the most important point that you need to observe? I'm going to tell you only one technique, which you can use it throughout this chapter. So why this is called as applications of derivatives is because in the previous chapter, we were concentrating on understanding how to use a tool differentiation. Now we are going to actually apply it, right? So when you talk about the formula that you're going to write, you need to ensure that the written equation, I want everybody to pay attention here. The written equation is a function of one variable. You have to convert it to that form and then start proceeding. Okay. You need to write it as a function of one variable and then you will start proceeding. So when you say rate of change, you're going to differentiate a given function mostly with respect to time. That is what rate means, right? So I hope everybody knows this. And is there anyone who has not learned this chapter at all? So if you can let me know, it will be helpful. So everybody has learned this, right? Okay. Next is increasing and decreasing function. So when do we speak about this increasing and decreasing function? So if a function is given to us, what are the conditions that we use to prove that the given function is increasing?
F dash of x.
F dash of x is greater.
So there are two conditions, right? Greater than or equal to 0, f dash of x is greater than 0. So when they use, see, as per textbook is what I'm explaining, okay? When they use the word increasing, which one will you use?
The first one.
So this is the one we need to use. When they use the word, the function is increasing. Then when are we supposed to use the second one?
Strictly.
When they use strictly, or this is very rarely used in CBSE, monotonically. Monotonically increasing. If they use this word, then you need to use the word greater than 0. So if f double dash of x is less than or equal to 0, you use it for decreasing. And if f dash of x is strictly less than 0, use it for strictly or monotonically decreasing. Right? So I hope this point is clear. Next is maxima and minima. So what are all the tests that we have for derivatives? So what are the tests that we have? So when I talk about the first derivative test, if I say f dash of x is equal to 0, then what condition does it represent? Does it represent a maxima or a minima? So if I differentiate a function in equal to 0, I'll get the values of x, right? What can you conclude? At those values of x in the domain, is the function going to be attain the maximum or minimum?
Sir, actually that at that point it will change, right? Change it occurs.
So this is the condition for both maximum and minimum. So since we are facing this challenge only, what do we need to do? You need to go with the second derivative test. So when you do the second derivative test, if f double dash of x, if f double dash of x is less than 0, okay, see when I do f dash of x is equal to 0 and I get x is equal to c, for instance, okay, then when I do the second derivative test, I'll take this f double dash of c. See, if f double dash of c is less than 0, what is that I can say? At c, what do you have?
Maximum.
You have a maximum. And f double dash of c is greater than 0, then at c you have minimum, obviously. Right? So this is what you do with the second derivative test. But is there a possibility where you can verify whether the point has attained maximum or minimum with the help of first derivative itself?
Yes, sir.
We can see if it's an increasing or a decreasing function on the either side of the.
Yes. So when I do f dash of x is equal to 0 and I get x is equal to c, suppose let's say the function is like this at one place and the function is like this at another place. This is the point c. Okay. So on the left of c, what should happen to the derivative? If f double dash of c minus is less than 0 and f double dash of c plus is greater than 0, then at c what is happening?
So shouldn't it be f dash of c minus?
Oh, sorry, f dash of c. F dash of c minus and f dash of c plus means the first derivative on the left hand side of c and the first derivative on the right hand side of c changes from negative to positive. At c, what will happen? You will have a point of minimum, right? Whereas at point c, on the left of c, if I take the slope, so f dash of c is greater than 0. Sorry, c minus is greater than 0 and f dash of c plus is less than 0. What is at point c? At c you have maximum. See, this is used very rarely. Okay. Suppose you get f double dash of c also equal to 0, then what will that point c be called as?
Point of inflection.
It's called a point of inflection. So if f double dash of c is equal to 0, then it's called as the point of inflection. Right. So this is all with the theory. Only challenges we should know how to apply them. So with this knowledge, are we ready to get started? Shall we start solving the problems?
Yes, sir.
Perfect. So you're going to take the question from here. Every question I'll give you 2 minutes time and you're going to come up with an answer. So find the maximum value of 1 by x to the whole power x. It is 1 by x, the whole power x.
So is it option A?
One minute. I have to check. I don't know. Option A is correct. Anyone else with the answer? Kaushik, is that you?
Yes, sir.
Okay, so if your option A is right, if you're done with this, start doing the next problem. Others? Still going? See, since in this problem, they asked what is the maximum value, you can stop with the first derivative test itself. So what is the function given? Y is equal to 1 by x to the whole power x. So log y will be equal to x into log of 1 by x. Right? Or you can have minus x log x. So 1 by y into y dash is equal to minus of x into 1 by x plus log x. So y dash will be equal to minus of 1 by x to the whole power x into 1 plus log x. So 1 by x to the whole power x, what will be the domain of it? X belongs to real number, except it cannot take 0. Right? So this 1 by x to the whole power of x, if I equate y dash to 0, this can go to the other side. So log x is equal to minus 1, which implies x is equal to e power minus 1. Which is 1 by e. So log x is 1 by e means what is going to be the function value? Y is equal to 1 by e to the, e to the power of 1 by e. Okay. Next. The length of each side of a trapezium is k. Its perimeter when it has the greatest area. Find the perimeter when it has the greatest area.
Sir, can you show that before slides?
One minute. I don't know why this is coming one. Any doubt there?
No, sir, got it.
Anybody with the answer for this? The length of each side of a trapezium is k. Its perimeter when it has the greatest area is. Is there anyone who's not confident in how to solve these kind of statement problems? Sorry? So listen. They have told that there is a trapezium. That there is a trapezium. And each side here is going to be k. So when I drop a perpendicular from here and here, okay, I need to find what? Find perimeter when area is maximum. So what is going to be the area of the trapezium? Area is equal to half into base into sum of parallel sets. Right. Now tell me one thing. How much is this distance? It is going to be K. How much is this going to be? That's where the question is. So what are we supposed to do? Can we directly start solving the problem, or do we need to introduce a parameter? Since I have right angle triangles, what is more better for me to start with? I can start with angles. So if I take this angle to be alpha, this will also be alpha because they're symmetric. Am I right? So how much will this
Sir.
tell me?
Sir, area it's half into height, right? Height into some others.
Okay, half into, see, I took this side. Okay, so half into height into some of the parallel sets. So x by k is equal to cos alpha. Am I right? So x is equal to how much? K cos alpha. If this side is k cos alpha, how much will this be? This will also be k cos alpha. Now tell me what is going to be the area. Half into height is how much? This is k sin alpha.
K sin alpha.
So this is k sin alpha into sum of the parallel sides. That is going to be k plus 2k times cos alpha. Now if I observe, area is a function of whom? Area is a function of alpha. Can I say that? Can I say that or not? So first listen, A is equal to k square sin alpha by 2 plus k sin 2 alpha by 2 because 2 sin alpha
sir.
plus alpha sin R. Tell me.
Sir, how can you take both the angles as alpha? They can be different also, alpha and some
They're
other angle.
symmetric. No, they told all the sides are equal. They told it's symmetric. This is K, this is K, and this is K. So angle should be the same.
Oh, okay, sir, got it.
Yeah. So that's what I told in the beginning. They're symmetric. That is why it is same. So area is a function of alpha. Now tell me what is the value of A dash. So do and tell me.
Sir, I have a doubt.
Tell me.
Sir, sum of parallel sides, right? So here one side is K, and other one should be
K plus 2 times K cos alpha. Da. There is already K because I've dropped perpendicular, it became rectangle. So K plus 2 times K, 2K cos alpha, no?
yes, sir. It is one side, right? Then the parallel side should be
Parallel side is K. Oh, so you're saying here 2K should come, no?
yes, sir.
Oh, correct. I'm sorry. So it will be K square. Then it should be K square sin alpha. K square sin alpha plus K times sin 2 alpha by 2. So differentiate this. Fast. So differentiate this and tell me what is the value of alpha you're getting.
Sir, how is it 2K?
This is K.
Sir, isn't it K only? It's K plus 2K cos alpha.
This is K plus what is the opposite side length? K plus 2K cos alpha. That's what he's asking. Where did the other K go? Got it? Subhajit, am I clear or not? See, the top side is K. top side is k. What about the bottom side's length? There are 2k
Sir,
cos.
Sir, could you please mark points A, B, C, D with
Yeah.
the
A, B, C, D. I'll take this as E and F. What is EF? EF is K.
Sir,
What
EF
is
is K, DE is K cos alpha, and
EC
FC is also K
F
cos
is also
alpha. So 2K cos alpha plus K.
plus K. What about the opposite side? Some of the parallel sides, no. You need to take.
Oh,
the side of
okay,
AB
sir.
also.
Got it, sir.
Yeah.
Got it, sir.
Anybody with the value of alpha? Unfortunately, a slightly tougher problem came.
Sir, instead of taking the angles, you could actually take it as a Pythagoras value, right? Like,
So you want to take this as some side and then do it?
yes, sir. Like instead of k cos alpha, we could take it as x itself. So the other side will become the AE will
Root
become
of
root of k square minus
x
x
square
square,
minus
which
x.
will in turn be the whole thing will be solved in one variable, right?
Now, here also it's one variable only. No, alpha is the only variable.
Yes, sir.
It's the same thing, ma. Whether trigonometry and Pythagoras theorem are related. If you're comfortable with handling square roots, you can go with that method. If you're comfortable with handling trigonometric variables, you can go in this method. You can do in that method. I'm not saying you should not do it. By doing it, did you get the answer?
Yes, sir.
What is the answer?
5k, sir.
5k?
Yes, sir.
But that's not what is given here. That's not what is given.
I'll check, sir.
Yeah, check once. No?
Sir,
Mhm.
with respect to what are we differentiating?
With respect to alpha, alpha is a variable, no?
Then it's K square into cos alpha plus
K times sine
K
to alpha.
cos alpha. No, sir. K cos 2 alpha. I mean,
Okay. Equate it to 0 and then find it, no? I want the final answer. Is it getting big? So you guys have to tell me what is the issue now. Why am I having so much of silence? What is the problem? That K is disturbing. Huh? 1 minute, 1 minute, 1 minute. This K into K should have been K square here. No, it is actually K square.
yes, sir. It's K square.
I think that K was disturbing you. K square into cos alpha plus K square into cos 2 alpha. Is this what you got?
Yes, sir.
This should be equal to 0. So cos alpha plus cos 2 alpha should be equal to 0. So what will you get? How much?
2. 2.
Cos alpha plus cos 2 alpha, you're getting 2. See, it is 2 cos of 3 alpha by 2 into cos of alpha by 2, which is equal to 0. So 3 alpha by 2 can be pi by 2 or alpha by 2 can be pi by 2. So these two will get cancelled. Here you will get alpha is equal to pi, which is not possible. This and this get cancelled. Alpha is equal to pi by 3. This is possible. So alpha is equal to pi by 3. Just take that value and substitute it back. No. Okay, let's
Sir,
forget.
but we
Okay,
need to check, right, the double differentiation.
no need. See, there is going to be a question where they are saying maximum, right? Only you need to check it. This is an MCQ, right? You need to check it only when you don't have any option. None of these you need to check. Okay, so forget it. We'll start with some simple problems. We'll start with this. Do the 14th one. So let's hold this problem. Don't worry about it. We'll do it at the end. So look at the 14th one. AB is a vertical lamppost and CD represents man. The man walks towards the lamppost at 180 centimeter per second. How fast is the shadow diminishing? So by the way, the answer for the previous problem is 4k plus root 2k. Okay. Answer for this. So if I take this point to be E, you need to find the rate at which DE is decreasing. Answer. Still not done. What is happening, guys?
Sir, 60, sir. Minus
Correct.
60.
Minus 60 is the right answer.
Sir, it is diminishing, right? So it should be 60.
Diminishing, no, minus, because it's decreasing, no? Diminishing, not the minus 60.
Sir, we'll tell like decreasing at the rate of 60. Right?
But here there are both the options, no? Minus 60 and plus 60. Which one will you take? So minus the
Yes, sir.
Yeah.
Sir, by looking at the option itself, we can obviously tell it's minus 60, right? Without
Because
even
it's
solving.
420. Yeah, you can't see. Option is supportive here, but what if it is not?
Yes.
So 420 is definitely not possible. So how did you guys do it? I want to do it in a minute and show it to people who couldn't solve. So 14th. Right, here is a man, A, B, C, D. Okay, what are the sides they gave? There's one problem. So A, B, C, D is given like this.
Sir, I can tell you the values.
Yeah, please. So how much is it?
Sir,
This
CD is
600.
150, 600, 150, that's it. Sir.
Okay. So how did you proceed? What did you take the side BD as?
Sir, I took it as PD only, sir.
Okay, you didn't take any variable.
Yes.
Okay. See, this is Y. This is X. Okay. Then 600 divided by Y plus X should be equal to 150 divided by X. Am I right? Which implies
Yes.
Y is equal to how much? Y is equal to how much? Tell me. So this will go 4 times. So 4x is equal to Y plus X, which implies Y is equal to 3x. Right. So dy by dt should be equal to 3 times dx by dt. What is the value of dy by dt? 4 minus 120. How much is it?
Yes.
Minus?
No, sir.
Minus
Minus
180.
180,
Minus
yes, sir. Minus 1.
Minus 180 centimeters per second is equal to 3 into dx by dt. So dx by dt will be minus 60 centimeters. That's it. But did you understand why I wrote it like this? It's because if I take this to be theta, tan theta, or you can use similarities of triangles, both will give you the same reason. Okay. Can we do little faster?
Sir, so it's minus 60 here.
Minus 60. Because for the unknown, you will not take. No? If, when I differentiated, see dy by dt, I took dy by dt, I put it as minus 180. So dx by dt is not known to me. So unknown, you will not give a sign. So dx by dt came out to be minus 60. So that is what you need to report.
Okay. Okay, sir.
Got it? So 15th one. The sum of values of x that represent the points of relative optima of function f are defined as. I think they are relative optima, they are talking about maximum.
Sir, is it absolute maximum?
So between the 0 to pi, check where all this function attaining maximum or minimum. Optimum means it can be either maximum or minimum. So your job is first find f dash of x equal to 0 and find out the values of x for which f dash of x is 0. What will be the answer? It's actually a good
Sir,
question.
within the domain, nothing is satisfying.
Nothing. Are you sure?
Sir, it's coming sin x is minus 1 by 2.
See, differentiate minus 2 sin x plus 1 is equal to 0. So sin x will be half.
Oh, okay, okay, sorry. Sin x is half.
The written derivative of cos x as sin x.
No, sir, actually, I didn't do it. I just did it in my mind, sir.
Mind, okay. So here when they say relative optima, right? Some of the values of x at which it is attaining maximum and minimum as well. It's a good problem. Mark it as important and try it. Can you do a little faster, guys? Today the response is a little less. So f of x is equal to 2 cos x plus x. What is the domain? X is greater than or equal to 0, less than or equal to pi. So f dash of x is equal to minus 2 sin x plus 1. So if I equate it to 0, I'll get sin x is equal to half. So between 0 to pi means the first interval and the second interval, sorry, first quadrant and the second quadrant. What are the values of x that I can take?
Sir, pi by 6 and 5 pi by 6.
pi by 6 and 5 pi by 6. Similarly, whenever there is a problem where in the domain itself, the extreme values are included, you need to take those values also into consideration. So what will be the sum of all x values? It will be 0 plus pi by 6 plus 5 pi by 6 plus pi. So had they given it as strictly greater than 0 and strictly less than pi, then you should not take the extreme values. You should take only the pi by 6 and 5 pi by 6. Are you able to understand? So when you add everything, you will get pi plus pi. Correct only, no?
Yes, sir.
It is 2 pi. Is there an option?
So 3 should be the answer, right?
Engada 3?
Oh, okay.
3 varadra.
No, sir, I substituted 2 pi in the function.
Okay. It is 0 to pi actually. I understand.
No, sir, I substituted 2 pi in the f of x, sir. So,
But why did you do 2 pi? Purila, why did you do that?
I thought
Was it
the
only-
maximum or minimum value of that function, sum of that.
So if you read the question, no, so what are the sum of the values of x that represents the point of relative optima of function?
Yes, sir.
புரியுதா? So maximum value of f of x is equal to sin x in the interval pi to 2 pi. Maximum value, not the maximum, not the point of maximum. So f dash of x is cos x. So where will you get the maximum value? In the interval pi to 2 pi. Pi to 2 pi belongs to the third and the fourth quadrant. Answer.
1, right?
How will it be 1? It's simple logic. Even without solving, you can tell. Can you get the maximum value 1 by root 2? Can you get 1? You cannot, because
0.
Sir, 1 by root 2.
1 by root 2 you can't get. What value
Oh,
of x
sorry.
is,
See. Yes, sir.
what value of x in the interval pi to 2 pi will substitute to get a positive value from sine? You can't.
Understood, sir.
So answer is, what is the answer?
0.
0. So I'll do this and show. So 16th question, f of x is equal to sin x. See, this is one point I would like to stress, guys. Whenever they have given you the interval across which you need to check whether it is a closed interval or a open interval. So f dash of x is equal to cos x, which is equal to 0. So what will be the value of x? X is equal to 3 pi by 2. Am I right? Now, what we tend to do is you will check what is f of 3 pi by 2. You will get the answer as minus 1 by root 2 and you will report this as the maximum value. But that will be wrong if the extreme values are included. If extreme values are included, you need to check the function value at the extreme points also. F of pi is 0. F of 2 pi is also 0. So among these three values, which one is the least value? Sorry, maximum value. 0. For example, had the question been pi to 2 pi, what will be your answer? That if it is open interval pi to 2 pi, what is the answer you will report for the same options that is given?
None of these.
None of these. Got it?
Sir.
Tell me.
Sir, at the end of the session, I have a doubt in one problem, sir. Can I just dictate it out?
Yeah, you can. You can.
Okay, sir.
Yeah. Do the 23rd one. Do the 23rd one. A spherical balloon is inflated so that its volume is increasing at 40 centimeter cube per second. How fast is the surface area increasing when its radius is 8 centimeters? It's a textbook problem. Answer? So
Sir, is it 10?
10, no? I have to check. Problem number 20. 10 is correct. So let me do it. Kaushik, tell me how to do. So volume of a spherical balloon is inflated so that its volume is increasing. So volume of the spherical balloon is 4/3 pi r cube. So what is given? dV by dt is equal to 40 r. Now they asked how fast is the surface area increasing. What is the formula for area? 4 pi
R square.
r. So which implies dA by dt will be equal to 8 pi r into dr by dt. So if I differentiate this, what will I get? dV by dt will be equal to 4 pi r square into dr by dt. So this will be equal to 40. Am I right? So how do you find dr by dt? So dr by dt will be equal to 40 divided by 4 pi r square. Take this and substitute it here. So 8 pi r into 40 divided by 4 pi r square is what is dA by dt. So 4 pi, this will get cancelled, r is gone, which implies dA by dt at r is equal to 8 is going to be 80 divided by 8, which is going to be 10 centimeter per second. So this is the answer. Okay. See, tell me one thing, are these problems tough or what is the reason? I'm not able to understand? Like, are they slightly tough or what? Why is no one responding today? Generally, you guys answer and do it fast. See, if it is tough, let me know so that I'll come with better problems tomorrow. I'll try to tone down.
Sir,
Tell me.
actually the problems like substituting the variables are like slightly hard, sir.
Okay, I'll do one thing. I'll come with a slightly lesser.
Sir, actually, could you keep it the same level?
I'll give you this is the assignment. You guys, you sit and work. I don't have a problem. You sit and work, but on a common interest, like I will try to slightly tone down. Tone down in the sense I'll go to the CBSE level. This is slightly to the exemplar level. Okay. So this is the worksheet that you're going to get. So sit and work on that. You have any doubts, you can reach out to me. But in the class, I'll discuss slightly. I'll do one thing. I'll discuss the previous year questions tomorrow. Okay. So can you try the 26th one? The function f of x is equal to x square minus 4x plus 6 is strictly increasing in the interval 2 to infinity. Is it right? Check it. So in mind, you can do that problem. So f dash of x is 2x minus 4. So 2x minus 4 is greater than 0, is x is greater than 2. So 2 to infinity, it is increasing. And minus infinity to 2, it is decreasing. Am I right?
It's true, sir.
So which
The
option
assertion.
is right? Option B or A? So which option is right?
Option B.
Option
Option
B
B,
is
sir.
right. Yeah, it is B is right because assertion speaks about increasing. Reason speaks about decreasing. So it is reason is not related to the subject. Right. So both are independently right, but R is not the correct explanation. It's not the supporting statement for the assertion. Okay. Next. Do the 27th one. F of x is equal to tan x minus x. So tan x minus x always increases, meaning it is always greater than 0 for any real number. Check that.
It's true, sir.
It's true. Both are true. Huh?
No, sir. Only the first one. The second of it.
Second one is not true.
It is true, sir. It is true.
It is true.
Sir, option A, sir.
That's right. So tan x minus x. So secant square x minus 1. So we know that secant x is always greater than 1. Right? So secant square x minus 1 is always greater than 0. So it's an increasing function. Both A and R are true, and R is the correct explanation for A. So we'll do one last problem and then we'll wind up. Okay. If two positive numbers are such that the sum is 16 and the sum of their cubes is minimum, the numbers are 8 and 8.
Sir.
Ah.
Sir, could you go back to the solution notes? The previous one?
Mm-hmm. 1 minute, please. It can be greater than or equal to 0.
Okay, okay. Yes, sir. Got it, sir.
So if two positive numbers are such that the sum is 16 and the sum of their cubes is minimum, then the numbers are 8 and 8.
Sir, it's false.
Without solving, how are you saying?
Sir, okay, cube, because maximum is half, but
See, x cube plus y cube should be a minimum.
sir, no, sir, if the condition was maximum, then it would have been 8, I think.
Sum of their cubes is maximum, okay? No, no. It's
Okay, sir,
minimum.
if it was square, I think. Sir, because I remember you only told that if two numbers square is
That is
maximum,
the
then they
problem.
should be,
They should be the same numbers. See, that's what is there in the textbook.
yes, sir.
So from that we took an observation. Is it 8 and 8?
Yes, sir.
Yes, sir.
Assertion is right. Okay. If f be a function defined on the interval I such that c belongs to I, and let f be twice differentiable at c at x equal to c, the point of local minima, f dash of c is equal to 0 and f double dash of c is greater than 0. Correct. So both A and R are true, and R is the right explanation for A. Correct. Option A is the right answer. Okay. So I'll do one thing. Tomorrow's class, I'll bring in some previous year questions of CBSE based on the different subtopics. We'll sit and solve that. Okay. Is there any other question that you have?
Sir, I had a doubt in one question.
Yeah, that I'll clear it. Apart from that, on a common forum, is there anyone having any other question that you want me to answer? Nothing? Okay, then we'll wind up.
Thank you, sir.
Thank you, sir.